Now imagine we were asked to calculate the value of the function e to the power of minus 2x when x was equal to 0.1. Well, we could simply use our calculator and get the value of the exponent e to the power of minus 2, which would give us 0.81873. Now, we could also write the function as a power series, and a power series is a series of terms with increasing powers of x as shown in the following expression. So, how do we get this power series? Well, we could use a theorem called MacLaurin's theorem, and MacLaurin's theorem allows us to express certain functions as a power series. And the theorem is given by the following expression. Now, as you can see, the power series is made up of expanding terms in x, and also requires the first, second, third, fourth, fifth derivatives, and substituting 0 into these values of the derivatives. And the greater we expand the terms, the greater the power series will represent the original function. So let's have a look at an example where we use MacLaurin's series to show that e to the power of minus 2x is given by the following power series. And we're also asked to show that the value of the power series when x is equal to 0.1 is 0.81873. So to prove this, we will use MacLaurin's series and expand it to the sixth term. So if we write down the function fx is equal to e to the power of minus 2x, first, we need to carry out successive differentiation of this function up until the fifth derivative. So if we differentiate the first time, remember when we differentiate e to the power of minus 2x, we write down e to the power of minus 2x and then we differentiate the index. So differentiating minus 2x, we get minus 2. And we multiply this by the original function. So the first derivative is minus 2 times e to the power of minus 2x. Now, the second derivative, again, we write down e to the power of minus 2x. Differentiate minus 2x, we get minus 2. And multiply minus 2 by minus 2, we get 4. And similarly, for the third derivative, we get minus 2 times 4, which is minus 8 times e to the minus 2x. The fourth derivative will be minus 2 by minus 8, which will be 16 times e to the minus 2x. And the fifth derivative will be minus 2 by 16 minus 32 times e to the minus 2x. We now need to substitute the value of 0 into each of these terms or derivatives to give us the coefficients within the series. So, substituting 0 into the original value of the function will give us e to the power of minus 2 times 0, which is e to the power of 0, which is 1. If we substitute 0 into the first derivative, again we get e to the power of 0, which is 1, and multiplying by minus 2, we get minus 2. So if we repeat this for the second, third, fourth, and fifth derivatives, we get minus 2, 4, minus 8, 16, and minus 32. We now substitute these values or coefficients into the original MacLaurin series. So for f0 we put 1, for the first derivative we put minus 2, for the second derivative we put 4, and so on. And this will give us the following expression. Now remember, 2 factorial is 2 by 1, 3 factorial is 3 by 2 by 1, 4 factorial is 4 by 3 by 2 by 1, and 5 factorial is 5 by 4 by 3 by 2 by 1. So if we calculate these values and substitute, we get the following expression. 2 will go into 4 2 times. Divide above and below here by 2, we get 4 over 3. Divide above and below here by 8, we get 2 over 3. And divide above and below here by 16, we get 2 over 15. So substituting these values will give us the final power series for the function e to the power of minus 2x. In part 2 we were asked, hence show e to the power of minus 2 times 0.1 is equal to 0.81873. So from part 1 we showed that e to the power of minus 2x was given by the following power series. So substituting x equal 0.1 into this series, we get e to the power of minus 2 times 0.1 is equal to 1 times the following. And if we calculate these terms out, we get the following, which when we add up will give 0.81873. And this was the value that we got originally when we typed e to the power of minus 2 times 0.1 into our calculator. So here's a question that you could now try. Use the MacLaurin series to determine the first 5 terms of the power series for e to the power of x over 2, and hence determine the value of e to the power of 1 over 2. and the answers to part 1 and 2 are given here.